Great. And so we can move into the next section here, where we're going to learn about this really helpful and super important package called readr, which, if you've used RStudio before, and even if you haven't used the Tidyverse, you've probably used it in some way or another. And so, in fact, you've actually seen this before if you watched all of our videos for our sort of introduction to this workshop. Um, but before we sort of get into the actual functionality of the package and all of the functions within it, I just want to give you an idea of what problem it's trying to solve. And so a lot of formats that we're used to on our desktop, Excel files, Microsoft Word files, doc files, etc. Um, these are really difficult to work with just because there are a lot of extra characters saved in the file that we might not actually see. And so I went ahead and sort of did an example to sort of just give you a sense of how much formatting actually goes into Word documents and things along those lines. And so if you have a plain text file or a TXT file that says hi, so you have HI and an exclamation point, so there's only 3 characters total. When you save this on your hard drive, it's just going to be 3 bytes of data, so one for each of those characters. But if you open up a Word document and you type the exact same thing, so HI with an exclamation point and then save it, there's actually 11,881 bytes in there. And so the difference is all in formatting. And so basically, there are a whole series of files that avoid this formatting, and they're essentially called flat files. So these are text files or TXT files, .csvs, which are essentially the Excel equivalent of, or they're essentially spreadsheet equivalents, so the plain text equivalent of spreadsheets. There's TSV files, and then there's binary files. And so again, like I mentioned, these are all flat files, and they're just the text with no additional formatting. And so it's really common for data scientists to essentially work with these types of flat files because they're smaller in size and they're way faster to actually parse. And so the Tidyverse package readr essentially has a function to parse each type of flat file, so text files, CSVs, etc. And so the one that is most common is the CSV, and that's something I've actually already showed you in the GUI, but we're really going to get all of the really detailed information about how to sort of customize this function to do a lot of good work for us. So we can sort of take our data from sort of a raw file and import it into R so it's usable. And so a little bit about CSVs. You're probably familiar with the main idea. So they're very similar to Excel files. You can export an Excel file as a CSV. But the difference is instead of all of the extra formatting, they're just comma separated values. And so that's actually what CSV stands for. So comma dash separated values. And really all that means is that the sort of rows and columns are separated by comma as sort of the um, uh, designation, if you will, in the file. And so it is very similar to how you would already think about data. So if we saw this example down here and I have name, comma, number, well, we would expect that there's one column named name, there's a comma separating them, and then afterwards we're going to have number. And so if we look at the rest of this data frame, we see exactly that. So we have a name here, the number, name, number, name, number, name, number. 1, 2, 3, 4 rows, 1, 2, 3, 4 rows in the second column. And the only formatting that we have to denote that is the comma. And so that's sort of how it's coming into a plain text file. It's just characters. And so read CSV is the function for comma separated values that is based in the package readr. And so readr has, as I mentioned, a function for each of these different types. But what's nice is all we have to do is just load that one specific package. So load via the library function, readr. I'm going to go ahead and run that. And we see all the sort of documentation in the help file over here. So we're able to sort of read those files, and specifically it works on CSVs and TSVs, and it turns them into a tibble. So we don't even have to do as tibble, which is really nice. And so when you're sort of loading in a file, and I've shown you this before in our intro videos, but we need to set our working directory so we can reference the appropriate the appropriate file. And so you can either do this by going up to session at the top. So you go session, go to set working directory, choose working directory, and then click a respective file. Or you can do it directly in the command line by saying set working directory, open parenthesis, in quotes, the sort of base directory you want to be in. So in this case, it's downloads. And then you can just use read_CSV, which is our function, and then put the name of the CSV file that you want to load in. And it's really that simple. And so the only thing that you're seeing down here in my sort of console, which you probably won't see if you're doing this in the command line, is that, again, you only change the working directory in this chunk. So this code chunk up here. So if I went and loaded this down here in the actual console, you're not going to get that warning message. So don't be worried about that. But when I read in the CSV, just with this simple one-line command, we actually get our data. So in this case, it's US housing prices. And so we have a data point for the US. We have each state. It tells us that that's a state. This is the region type, so country, and so forth. And then we have all of these prices and dates up here. Now you've probably noticed that there's actually something wrong though with the way that this data has been loaded in. So if we know that this is the sort of set of columns in the data set up here, it's a little strange that we have this US Zillow home value index in the first column, and then an ellipses, the number 2, and as we go through here, it's 3, 4, 5, 6, 7, 8 for the column names. So these are the actual column names. And that's not actually what we want. What we want is this data type and the date to actually be the column names. And so it turns out what read CSV is doing is it essentially is just assuming that the first line with all of those commas in between is the appropriate column names instead of what we would assume, which is the title of the file. And so what we want to do is we want to use this command right here, the skip command, to skip the first line. And so when we load this in, we're actually going to ignore the title, and then this first row in this first loading is going to become our new column values. So if we go ahead and do that, we see now we have region name, region type, data type, and dates. And so those are exactly what we would expect. And then everything after that is appropriate. Great. And so we're all set now, but we also want to sort of be aware that sometimes there is metadata in our data set. And so we might know that by actually looking at it, but if we load it in once and there ends up being an issue, we can go back and reload it. And so if we have that metadata, so title, descriptions, etc., we can actually ignore it relatively easily. And so if it's broken up into lines, which is really nice, we can go ahead and just skip 2 lines. But if it's something like a comment, which in R is a sort of a number sign here, we can actually tell read_CSV that we want to ignore every line that has a sort of hashtag or number sign in front of it. So these 2 lines of code are going to load in this manual data set that we're creating that has this first line, a second line, then the values X, Y, Z, and 1, 2, 3. In this first one, we're going to skip the first 2 lines because it's nice that these are broken into 2 lines, and we'll see that it actually loads exactly what we would expect. So X, Y, Z, and then the values are 1, 2, 3. Great. So this third row becomes the first column, which readCSV assumes is the column names. In the second one, we have this hashtag in the front, and now we have this new comment. Instead of lines, it's going to be, these are the things we want to comment out, and we've specified that it's the $sign. So when we run that, it's going to ignore this first line, treat this second line as the first one, and then those are going to be the names of the columns. So we have XYZ, 1, 2, 3. Great. So just be aware, if you have metadata, it's very easy to skip it, so not an issue. Now, if you have no column names, we can actually assign them, or we can tell the sort of readCSV function that we want to ignore them. So let's say that we have a CSV where there's no column names and there's sort of 2 rows, 1, 2, 3, and then in the second row, 4, 5, 6, and there's 3 columns, but we want to add those column names. We can just use our normal function, have a comma, and then have this new input, so call_names, and then specify the actual names here. And so you'll recognize from the intro video that this is just the concatenate argument. So C, open parenthesis, and then you list the actual values. It's going to combine all those into one vector, and then it's going to apply that vector to the data set. So if we run this and see it in action, we see that our XYZ now becomes the column names, and then we have our 1, 2, 3, and then our 4, 5, 6 in the second row. If it wasn't already apparent, this sort of \n is just saying to add a new line. So at the end of that, it's going to add that new line down there. Great. So if we want to do the same thing, but we want column names to be false, so i.e. we don't want to assign any new column names, readr will actually assign names for you, so you don't have to commit to anything, and it will be x1, x2, x3, all the way up to the number of columns that you actually have. Great. And so one other common sort of argument that you'll make within the readCSV function is sort of this NA argument, which tells the readCSV function where your missing values are. So if you have a bunch of missing values, which is very common, you can sort of tell them how it's denoted in your data set. So here it's going to be NA equals, and then in quotes, whatever the actual symbol is. And so if I make this 2-line data set that doesn't have any column names, and the values are essentially A, B, C, 1, 2, 3, or 1, 2, and then a missing value, where the missing value is NaN, we can tell the function that NaN is the way that it's denoted, and then it's going to parse it and put the correct missing value sort of structure in there, which is just NA. And so you can have periods where missing data is, you can have comments or things along those lines. But whatever it is, just make sure it's consistent. And I would highly recommend that it's not blank. So you can have it be blank, but it's going to give you all sorts of problems later on. So I would try to specify it in some appropriate way. So typically with NA or NaN or something along those lines. Great. And so those sort of basic arguments with readCSV are going to help you deal with pretty much 75% of all of the CSV files that you're going to encounter in practice. The 74% is the claim of the textbook that we're using. In my experience, that may or may not be true. So those are the core things that you'll use if folks who have collected your data sort of followed the original advice that I gave you at the start of this lecture, where we really want to be aware and think a lot about our data. But if you have a bunch of impurities in the data or mistakes in the data, or it's set up in a non-user-friendly way, you might be able to use the readr function, get it in there, but then we have to make a bunch of changes to it. And so that's actually what we're going to talk about now. So some of the actual changes we might have to make when we're parsing our data based off of the way that it's structured before it actually goes into R. And so before we go into this idea of parsing a file, I want to introduce this idea of parsing a vector. And I'm just going to do a very short version. I really encourage you to go into the textbook and sort of read through this because it's going to give you a really good idea of what exactly is going on underneath R when it's going and trying to parse a file. But I do want to just introduce the notion here in a simple way. And so R has a ton of, well, specifically Tidyverse has a ton of parse functions that all have similar logic. And so they basically take a character vector and then turn it into a more specialized vector. And so, you might be familiar from the last talk or the intro talks where I talk about different data types. We have logical functions, which are just true and false. We have integers, which are like numbers 1, 2, 3 without a decimal place. There are data types, and things along those lines. And so the parse functions will assume that it's coming in as a string, which in these cases they are because there's little quotation marks around it. And then what it's going to do when you use that particular function, so parse logic, parse integer, parse date, and so forth, it's going to go ahead and turn them into the appropriate data type. And so here it's a logical data type, integer, and date. And so in these cases, it was relatively easy for it to do that. A couple of, so essentially it does that for each data type, and readr builds on each of these parsing types to essentially guess what a data type it is. And I'll talk about that heuristic in a couple minutes. But something to note, especially for folks who don't engage with exclusively English text in their research. So for example, if you have a lot of characters from other languages, you will need to go into the textbook and read a little bit more about how parsing characters actually works. So if it's a much older language, so for example, there are certain characters that aren't commonly used in the UTF-8 system, you need to actually go in and specify what the encoding is. And it's easy to do, but you just need to be aware of it. So you just need to go in. It'll be the same sort of function where it's the parse character, you put in your data, but then you need to specify what the locale is. And there are a whole bunch of different options for that. So if there's special markings on a letter or extra characters, you just need to specify that. But definitely go in to chapter 11, section 3, subsection 2, and it's going to go in and talk about that. But all we need to take away from this short introduction is that when you're parsing a vector, it takes a string, and then R is essentially guessing the data type based off of what you've given it. So if you have questions about those, definitely go into the documentation and read more. But when we're moving into parsing a file, it essentially uses these parse functions and goes through each one to try to make sure or try to guess what exactly your data variable is. And so what read CSV does is it takes the first 1,000 rows of your data and then tries each of the following until one of them is always true. And so if it's a logical, it's looking for an F, a T, false, or true in all caps. And if it deviates from that, it's going to move on to the next one. So integer, so it's going to contain only numeric characters and the little dash here. If that's not true, it's going to move into double. So it contains only valid doubles, so numbers with a decimal point. If none of that is true, it's going to look for numbers, so it basically contains valid doubles, so numbers and doubles are related, but just with the special groupings. If that doesn't happen, it goes to time. So it's going to try to match the time underscore format, similar to the one that we already saw up here with date. Date, again, it's going to be the date format. So it's, again, highly related to time. And then finally, it's going to check a date time data variable. And so if all of these fail, so if none of them are true, it's going to stay a string. And so there are different ways that you can change this around. So for example, if you want it to read the first 2,000 rows to try to guess or something along those lines, it's going to, you can just specify that by saying guess max equals 2,000 and kind of go from there. But you really need to know that you're sort of like in the driver's seat, right? So this is just the guess. And I will sort of put a little correction here. It's not that it's always true, but it's just the vast majority of time it's true. Something is, you know, in this format. But anyway, so not always, just most of the time. But if, for example, this fails and you're very aware of how your data is actually formatted, you can just sort of specify what way you want to parse the data, and then it will just force it to be in that format. And so you might get some missing values, so NAs, just because it's confused, which is probably why it failed in the first place. But it's relatively easy to do. And so really all you're going to say is, the normal read CSV file, you're going to put in the name. So read CSV or challenge.csv in this case. This readr example is just because within the function, this is a data set that comes with readr, but normally you would just have read CSV, the name of the CSV, comma, and then you would say call types equals calls. So that stands for columns, open parenthesis, and then you're going to specify the actual column. So this is the name of the column. I'll show you just so it's transparent. The name of the column is X, so X, and the name of this column is Y, so Y, and then you're going to force it to be a particular form. So here it's call double, so this is going to force it to be a double, and then Y, call date, forces it to be the date. And then if we print it here, you can see what we just popped up down here. Great. And so this is just giving you a little bit of flexibility in terms of when you load your data, so you can force it to be a particular data type. You can change the heuristic it uses to try to parse the data. We have access to many different built-in sort of parse functions, so you have a lot of flexibility when doing that. But I also just wanted to reinforce that you can do everything that we just talked about, but actually in the GUI. And so I've showed you this before. It was in sort of the loading data set CSV into R, but all of those extra settings that I sort of waved off are the exact ones we just went over. So if you come over to import data set in the top right, and then do from readr, we can go ahead and do the same thing. So we're going to come down here, browse, and I'll just do example.csv. This one right here, so we can go ahead and open it. So you find your data, open it, it's going to retrieve and preview the data, and then it's going to load it in. And so you have this data preview, and it's going to show you how it's guessing about your actual data here. And so it's going to guess that all of these are doubles. Well, if I want this to be an integer instead of a double, I can just go in and specify that. And so now instead of a double, this is going to be an integer, and these here should be doubles here. I have all of these different functions down here. So if we want to change from a comma to a semicolon in terms of what's separating the actual values, we can change that. If we wanted to use our comment command, we can specify the symbol that's being used. If we want to specify what the actual NAs are here, you can specify them there. For the folks who are using non-English language text, you can specify the locale here just by configuring it. We can specify how many lines we're skipping here. So everything we just did in the console is possible, through the GUI, drag and drop, etc. The other thing that's nice about R is it generates the actual values or the actual code for you. So if you wanted to do this first by hand to sort of learn what it would look like in the actual command line, you can go ahead and do it once, copy and paste this, and then do it from there. If you import it, right, it's going to run it anyway, so it'll pop up down here, and you can just copy and paste this into an R script, and then it works well. So it's relatively convenient to do it in the GUI. So just want to point that out. And so the last thing that I want to point out in this section before we actually move into our Tidier crash course is, how do you do the reverse of reading in a CSV, which is essentially writing a CSV. So we're actually going to pause for a second and think about, jumping all the way to the end of our analysis. We've done all of our data wrangling and things along those lines. How do we write the file? Well, so readr also has a function, for each of the data types. In this case, it's write CSV since we're working with our CSVs, and it's exactly what you would expect. So we have, say, our tibble. So in this case, it's the TB from earlier, and we're going to put that in our first argument, and then afterwards we're going to have quotes, and within that we're going to name the file. So it's example.csv. And so in this case, how do we know where it's being written? Well, it's just going to wherever our working directory is. In this case, if you look at the bottom left, you can see the working directory is in my downloads folder. But you're going to go ahead and run that, write CSV. There's no output, but if you'll look in the downloads folder, it's going to be there. But we also don't even have to look visually. We can just try to load it back in. So if we do the reverse, which we just did up above, we could do read CSV, example.csv, and run it. And so what we see here is we get our exact tibble back, so the normal vals, pros vals, and transformation, the values, and things along those lines. But we also get some extra sort of information that was sort of saved in the original CSV. So it pops up down here, it pops up here. And what if we don't want that, right? This is all information that shouldn't be in the data set, so when we load it in, it's not necessarily relevant to us. Well, there's two ways that we can actually get around this. So we can write it as binary, and we can write it as binary either in RDS, which is R's version of binary, or we could use feather, which is another type of binary. So the commands are basically the same. So write RDS, read RDS, and that's going to write our tibble into a binary. We're going to save it, as binary.rds. So this is just the name. I'm going to read it back in. That way, we don't have that warning message when it comes in. So we don't have all this extra information. It's just the data that we need. So that's a great reason to use binary. You can also use feather, which is binary that works across different languages, so not just in R. And for this, you're going to have to do a little bit more work. So if you haven't installed it before, you're going to need to run install.package feather, load the library, and then you can use write feather, read feather in the exact same way. But once you've done that, it's going to load it in, and you still don't have that error message or warning message. So these are all similar. They're all very highly related. And you'll notice that all these different flat files are related, so you can sort of interchange them relatively easily through these functions, just like we saw. One sort of thing I've put here to give you an idea of which is better, if you're tied up with speed, feather is the fastest, just because it's optimized across other languages. So you find that in Java, for example, it's much faster. RDS, which is R's, again, R's version of binary, is a little bit slower, sometimes comparable to feather, but they're both much faster than CSV. So if you care about speed, use one of the binaries. If you don't care about speed, they're all just as good. Except maybe, we have that caveat with the CSV where you have the error message or the warning message. But feather and RSD are great options. So in a second, we're going to get into Tidier. So we just want to hop over there in a second. But I do want to just quickly clarify, when I've been saying this warning message here, it's not necessarily that we did anything wrong loading it in, but it's just sort of the extra information that readr gives you that is saved with the CSV when we write it, and then we sort of turn it back in. And so if you're writing CSVs sort of as an intermediate step in your analysis, so say we have some pre-processing pipeline, writes as a CSV, and then we read that CSV, which is pretty common across languages and across pipelines, we don't want this extra information. So that's a reason why you would want the binary. But if this is just your final data set that you're outputting, a CSV is just fine. So I just wanted to clarify that. I think I was a little too hand wavy with that. Great, but in a second, I'm going to grab some water and then we're going to hop in to the Tidyr crash course right here. And then after that, we're going to do our case studies. So I'm just going to show you them and you're able to do them on your own or in groups and then submit those for certification. Great, see you in a second.